Hello students, now we will continue chapter 6 decay 0 to 4 carbonyl compound, aldehyde and ketone. 6.4 chemical properties, part 4. Now let us see learning outcome. 2 Roman reduction to alcohol using lithium aluminum hydride followed by hydrolysis or sodium borohydride in methanol or catalytic reduction in the presence of catalyst. 3 Roman condensation with 2,4-dinitrophenylhydrazine 2,4-DNPH as identification test for carbonyl compound. Chemical properties of carbonyl compound. Our lesson today, chemical properties of carbonyl compound, we focus to reduction reaction and condensation. Reduction reaction of carbonyl compound. Reduction of carbonyl compound with reducing agent sodium borohydride in methanol. Reduction with sodium borohydride are most commonly carried out in methanol at room temperature, and lithium aluminum hydride is much more reactive than sodium borohydride. Unlike sodium borohydride, lithium aluminum hydride react violently with water and alcohol. Reduction using H+ are carried out in triether at room temperature. Aldehyde and ketones are most readily reduced with hydride reagent. Reduction of aldehyde and ketones by two similar reducing agents, sodium borohydride and lithium aluminum hydride. Both reagents are sources of hydride ion H-, which is very powerful nucleophile. Last, catalytic reduction. Catalytic reduction are generally carried out with metal catalysts such as nickel and platinum with high temperature. Attention, let me focus. Aldehyde can be reduced to primary alcohol, and ketone can be reduced to secondary alcohol. But for methanol, we reduce to methanol. Example 1. In aldehyde, can be reduced to primary alcohol using reducing agent lithium aluminum hydride followed by hydrolysis. Next, example 2. In ketone, can be reduced to secondary alcohol using reducing agent sodium borohydride in methanol. Formation of alcohol. This hydrogen come from the hydride reducing agent, and this hydrogen come from hydrolysis. Condensation reaction of carbonyl compound. Reaction between carbonyl compound and ammonia derivative. But our lesson today just focusing to 2,4-dinitrophenylhydrazine or 2,4-DNPH. 2,4-DNPH actually is a Brady reagent. So what is Brady reagent? 2,4-D NPH is a solid whose colors can range from red to white. It is a synthetic hydrazine derivative which is mostly used for the qualitative research of aldehyde, which is a ketone-related carbonyl group. To identify the presence of carbonyl compound, we can add Brady reagent or 2,4-D-NPH at room temperature. Positive test will be the observed of an orange precipitate. Reaction with 2,4-dinitrophenylhydrazine or 2,4-DNPH. Reaction between carbonyl compound and 2,4-DNPH is condensation, where both combine together and small amount of water or molecule water is eliminated to produce product to form dinitrophenylhydrazine. So this is general equation between carbonyl compound and 2,4-dinitrophenylhydrazine to produce 2,4-dinitrophenylhydrazine. So we need to know the structure of 2,4-DNPH for writing equation, and it is easier to remember the full name and structure together. So as conclusion, reaction between carbonyl compound with 2,4-dinitrophenylhydrazine, also known as Brady test. Brady test can be used as identification test for carbonyl compound. The observation, yellow or orange precipitate is observed. Okay guys, thank you. See you next video, part 5.